Are there any thoughts about what we've covered so far? Software. I don't know if people have had a chance to think about what we've looked at so far. It's a very strange cohort where students are just quiet and they don't want to ask questions, but you know, what happens when the right assessment is the complete opposite of what one would expect, right? Usually when you keep quiet, the thinking is almost always that you have a firm understanding of what has been discussed, right? But that's okay. I guess something else I wanted to kind of touch on. I'm not sure if I mentioned this before as we're discussing this lecture series here, but this idea that unlike some of these courses where the topics that you cover are not really closely related, the situation is slightly different in this course. I'm just going to pretend I'll call this person later on, it's fine. I was calling, when you said the venue was locked, I was calling the person responsible. Now we're going to look very silly, but that's okay. So it's okay when you look silly sometimes, right? But so my encouragement to you is, so two things. Reminding you, I think I may have mentioned this in one of our very first lecture series, but if I didn't, this is me letting you know or informing you that everything we are doing here is related, right? So if you don't understand what we're doing right now, you're going to find it incredibly difficult to understand these topics that we're covering. If you remember our discussion of abstraction, we said we're taking a top-down approach, right? Starting with the higher levels of abstraction. And we know from our discussion of abstraction that when you're dealing with higher levels of abstraction, it is incredibly easy for you to understand what's happening, right? Because you leave out the complexities, right? But as you're going deep down in the layers, the complexity increases. It turns out, right, it's a lot easier for you to understand that complexity if you know what's going on right now. So this is not like, I don't know which other courses you guys take where if you cover a topic and then that's it, right? The next time you revisit that topic is during the exam or when you're writing a test. No, right? The Von-Neumann, our discussion of machine structure will not make sense if you don't figure out what we're doing right now, you know? So I thought I'd mention that. At least people are a bit uncertain about that, we're not aware of that. So that's that. And then, I'm surprised here. Well, not really that I'm surprised. It's okay. You know, at the very beginning, there's usually a number of factors at play. I'm referring to the assessment now. There are usually a number of factors at play, like things that will tend to affect the performance of students, right? Generally, it's things like the anxiety that students would have. You're a bit uncertain about what is expected of you when you're attempting a question or something, you know, all those things. But to be honest, I mean, we worry when we see something like this, right? Seriously, worry when we see something like this, right? Is it when the day before yesterday the quiz, right? We worry when we see something like this because there's a bit of a problem here. And what I've noticed, right, or what I noticed is that it's like the vast majority of you did not bother to read the question. I mean, to read that, yeah, the question, the entire question, right? There was that detailed write-up associated to, is it AMMC or something? You didn't read that, right? What you did was you just rushed to the actual specific questions and you thought you knew exactly what was being required of you. There's a problem there. So what you will notice, and I didn't really add these comments in the scripts, but some of the things that you were responding to your responses to the questions make sense, they make logical sense, but they had nothing to do with the question. Right? So if you go to the if we were to go to the quiz, for instance, to try and see what we did here, there were obvious things like question 1, right? Yeah, question 1 was quite clear. Using the table below, this table here, state how the 2 categories of computer systems are utilized, right, in this organization, and you're told, you specify the staff position. The staff positions have been indicated up there. And it was nice to see a few of you, right, understand what this means. I guess, do you need an explanation for what this means here? Somebody asks you staff position and you are you're writing the category of the computer system here, right? Like you're saying it's desktop computer, and then, you know, you understand what I mean here? It's about understanding what is required of you. Yeah? And so sometimes, right, some of these questions, I guess the way that we assess to see if you understand the topic covered, for instance, sometimes, I mean, there'll be a lot of context provided, expecting you to do a little bit of thinking, but in certain instances, right, they'll be easy to understand questions, like here. You're asked, right? Remember our discussion of SaaS, PaaS, and infrastructure as a service, IaaS, right? You're told, right? Given an example, Dropbox, the one referred to up top, it's considered to be a software as a service offering, right? Tell us what the advantage is for a SaaS service in comparison to a PaaS service. And if you're wondering, well, what were you trying to assess here? Trying to see if you understood our discussion of what SaaS is, what PaaS is, and what infrastructure as a service is. And if you truly understood, if you read and you understood, if you attended classes, and if you understand what those things mean, it won't be difficult for you to come up with the solutions, right? Yeah. What is the advantage between, forget about Dropbox, right? Another example of a software as a service is what? Google Docs. What is the advantage of Lighton using Google Docs as opposed to him using Microsoft Word or Microsoft Office? Well, I don't have to install Google Docs. I just open up my browser and access Google Docs. If I need to upgrade the piece of software, I don't have to worry about that when I'm using a software as a service platform, right? Because everything is handled by the organization providing that service. Those are the things we're expecting you to provide us as solutions. But if you look at some of the responses, well, I mean, granted, I mean, almost everybody left this blank, really, to be honest, right? But if you look at some of the responses, the few responses that we received, things that don't really make a lot of sense, right? And I'm sitting there and I'm wondering, what is going on here? What is the problem, right? And I think the problem is you've decided to neglect the advice given to you. After every class, make it a point to go and do your own independent research so that you understand the things we're discussing in class. There's a guide provided at the end, the bibliography slide. Like, for instance, during our discussion of computer software, right, this discussion, there will be, where is that now? There will be reference, right? Like things that we feel you would probably be able to, you can potentially utilize for you to understand what we're discussing here. Not only that, I don't know how many of you have, if I was to ask, maybe people would just say, yes, me, right? But I don't know how many of you have bothered to, if you look at the screenshots that I provide, sometimes, well, almost all the time I'll have a link, right? And the expectation there is, if you don't understand that screenshot, I mean, sometimes the link is like just a link to an image, right? Because I want to credit the original source. I didn't create this image, right? So you have to credit the source. But the expectation is for those links, right, that could potentially provide you with additional details. The expectation is you're going to go out there as you are revising these slides, and then you go to the link. You check what is there. But you're not doing that. Well, I don't know if you're not doing that here. I didn't do any study to find out if you're not doing that. But maybe we can do a study right now. Who's doing that? Raise up your hand, right? Just nobody is raising up their hands. So you're not doing it. Right? You just did a survey here. We know you're not doing this. Or at least not the whole class is here anyway. So I sit there and I'm wondering what is happening, right? Really, it's quite surprising. Look at this question, to be honest, right? Server computers are fundamentally used to share resources, right? And we discussed this. We gave tons and tons of examples. Oh, Moodle, right? Server, right? SMTP server and all that. Nobody's going to ask you what does SMTP stand for. Nobody cares about that, right? Not in this course anyway. But anyway, you're taught, right? Servers will provide, they're fundamentally used to share resources, right? To a large group of users. Using this table, right? Tell us, by referring to the explanation provided up top, tell us how this organization uses servers, using the context provided to you. Right? There's mention there to say they use Dropbox to share resources, to store information. What we were expecting you to say is, you tell us which staff position is applicable, right? There's an accountant there, admin assistant, the senior vet, consultant, there's assistant vet, sales assistant, whatever. And what we're expecting you to do is you specify the role, and then corresponding to the role or the roles, you tell us the resource. We're not interested in you telling us, oh, it's a file server, right? What we're interested in you telling us is what resource, if it's a file server, right? What resource is being provided by the file server? And it's resource. So if you say file server, is a file server a resource? At what point did we say a file server is a resource, right? I didn't say that, and I have proof that I didn't say that because I record the classes, right? There's the recordings, but maybe unless if I don't abuse drugs myself, I was going to say unless if I was high, maybe I would have accidentally said a file server is a resource, but at no point did we say a file server is a resource. Understand. My advice to you is when you have a question, understand what the question is requiring of you. Don't rush, I know what most of you are doing. You neglect this piece of text here, very important for you to understand the question, and then you just rush to this table. So, using the table, and then you start scribbling things down, right? I don't know if you had memorized things here, but I could sense there were some people that probably did that. By the way, memorizing probably won't help you in this course. But some people are gifted like that, I suppose. Right? Like where you can suck in a lot of information. And so for you, memorizing is normal. You can manage to do this. But the vast majority of us, me included, doesn't help. So your best chance here is to read and understand. Do you understand this? No pun intended. Read and understand. You understand this, right? You know. But anyways, so I'm hoping, ladies and gentlemen, that we shall soon see a change. There's nothing funny about this, right? I don't like seeing this. Nobody would want to see this, right? I hope you will change. And on that note, I hope you've prepared for the quiz, which is on Thursday. And I know a lot of you are probably excited about maybe going home for the long thing here, but please study for the quiz, right? It shouldn't be difficult if you look at our discussion of abstraction. Very trivial stuff, to be honest, right? Just read and understand what abstraction is all about, or the different examples of abstraction that we provided, right? In what sort of context would you expect to use abstraction in computing? Remember that stack we made reference to? I don't know if we have it here, but what we are talking about here is this. All you need to do is understand this. What are we doing here? This. This, right? Our discussion of abstraction, if you remember, lecture series number 4, was primarily centered around this diagram here. And in essence, what we were doing in this, we spent the vast majority of our time outlining, right, what happens in these different layers here. So if and I don't think anybody is going to ask you this question, but just hypothetically speaking, if somebody asks you this question, could you, and maybe we can link it to what we're doing right now, right? Could you, if we think about, I don't know if this is the thing here, can you, if you remember our discussion of software, we were talking about instructions. That's a classic example. Implementation of software. We're saying, what do we do as part of implementation of software? We go through that SDLC cycle, but when the programmer is preparing the instructions, what we discovered is that, this is interesting here, what we discovered is that Programmers leverage abstraction when they are working with instructions. Like an example, right? So randomly somebody asks you, well, could you tell us how abstraction in computing is utilized or taken advantage of when developing software, right? Or when making reference to programming languages or programming language instructions. What we're expecting you to tell us is that, well, when you look at programming languages, fundamentally, you know, programmers will, for the most part, use high-level programming languages, right? Because they are relatively easy to understand. They are, however, abstracting what the computer is going to process, the instructions the computer is going to process, because the computer doesn't know what 4 is, right? So what the programmer is doing is, he is abstracting what the computer is going to see, what we're calling ones and zeros. Why is he doing that? Well, the why will be like, well, tell us, and maybe somebody will throw in a question like, still tied to programming languages, what would be the advantages of abstraction? Give us the obvious advantages of leveraging abstraction when developing software and writing program instructions. Obvious things here. If, for me to print numbers 0 through to 9, all I have to do is write 1, 2, 3 instructions, 3 lines of code. And if I'm to do the equivalent, like write the program, the same program in machine code or in assembler, I would have to write 19 lines. Then I'm more efficient, right? When I'm using a high-level programming language, is it? That's an obvious advantage. I am efficient. Well, I can quickly write program instructions using a high-level programming language. What other advantage is there? What? If you look at this and this, if you are writing just 3 lines of code and you're using easy to understand mnemonics or words or phrases like for and verb, then it goes without saying that if there's a problem and you need to fix that problem, here's a question for you. If there's a problem with the instructions you've written, which of these two would be easier to fix, right? This or this? These 3 lines here. Sorry? Yeah, well, this one, I'll answer, yes, it's this, right? You understand? That's an obvious advantage, right? So fixing of errors is easy, right? You can quickly write software. You understand this? You know, but anyways, and then we mentioned, if you're dealing with the lower layers of abstraction, some obvious advantages would be that you are more likely to write, efficient code, right? So because you are working at a very low layer, you can focus on these small little intricate details, making it possible for you to come up with, robust code or something, or very effective code. Notice I'm not talking about you being effective at programming, but the end result is likely going to be better because you're working at a very low level. You understand? It's like if you want to buy. I'm wilding out here, but I'm just going to use this example. If I wanted to buy a T-shirt, I think I need to upgrade here and buy a T-shirt. If I wanted to buy a T-shirt, in all likelihood, I'll end up buying something that's more durable if it's something that was hand-woven or something, right? Rather than something that goes through like a production line, right? You understand what I mean? Because there's a lot of care and attention to detail being placed there. Do you understand this? This is what we expect you to do, right? So if we are asked about examples, again, let's say we asked, give us, besides programming languages, right? Somebody asks you, these are obvious things. I'm giving you scenarios of what sort of questions would be asked of you, right? To see if you understand this whole notion of abstraction. Nobody's going to ask you what is abstraction. Well, maybe they will, but in this course, I will not ask you, I promise you. There will be no question, not in the test, not in the exam, not in the quizzes where you say, what is abstraction or define abstraction? It's pointless, right? How do we gauge whether you understand abstraction by just asking you what is abstraction? That doesn't make sense, right? But we will ask you, a very, I guess somebody would say it's a tricky question, right? Well, besides programming languages or making reference to programming languages, how else, in relation to program instructions, how else is abstraction taken advantage of? Give us another example of abstraction, right? This is where we expect you to tell us those details we're discussing, like, well, we have a layer of abstraction referred to as instruction set architecture, where there's a one-to-one mapping between the actual computer instructions, right, and the machine representation of what's going to be executed by the processor. Do you understand this? You know, so I don't expect, well, not that I don't expect here, there's nothing like expectation here, but I would be very disappointed and very sad if we had a repeat of this. If we had a repeat of this, please don't do this, right? Nobody really is looking at this. If we had if we have a repeat of this, I'll be very disappointed. Please don't do this, right? Let's be serious with what we're doing here. We did not come here to party, right? So if you've been partying all night every day here, slow down and focus on ICT 1110, not just ICT 1110 here, but these other courses. All right, unless there are questions here, please study for the quiz on Thursday, right? And I hope you'll be able to tell us here. More examples we gave of abstraction here. In fact, when we're going through here, we're showcasing examples of abstraction, right? Like the fact that when you perceive the computer like this at a very high level, it's something that you just instruct. You give instructions to, like you're typing an assignment or something. But it turns out that if you open it up, for instance, what you notice is that there are components, right, within there that play crucial roles associated with input and, you know, output and processing. Yeah. Anyways, oh, this is nice. Here's another way of looking at abstraction. We mentioned, right, in the class on Thursday it was, I think, say our top-down approach is constantly making reference to this diagram here, where we're showcasing the different layers of abstraction. But it turns out that if you can break these apart into the hardware component and the software component, right? So the top part is software. The bottom part is mostly comprises of hardware components. Yeah. All right. Anyways, so I mean, we went through quite a bit of slides here explaining different types of software, you know, desktop software, web-based applications. I hope you understand what it means when we're making reference to web-based applications or these websites. No, it is not applications that are accessible using a browser. No. Right? Because the reasoning there is flawed. What about Moodle when you're using the mobile app? Moodle is a web-based application. There's issues to do with the protocols that are used, right? And the fact that the service is located somewhere on a remote computer system, right? A server computer system in all likelihood. So what you're doing is, we spend a bit of time here to walk us through the process you go through. I don't know which one it was here, but I've forgotten where it was. When we maybe we didn't here talk about this, but I must have explained that, you know, when you're interacting with a web-based application, what you're doing is I don't know if it was this class, but I think it was this class. You send a request to the computer system that has that web application, right? And then you get back a response. Is it? Yeah? I don't know what's happening here. People are quiet here, all quiet on the Western Front. We also touched on the so-called software development life cycle. Not that I will ask how many phases that the SDLC have, right? Nobody will ask that so that you just write the answer 2, 4, 5. No. But what we'll be interested in seeing is if you understand what each of these distinct phases is all about when you're writing software, right? There's elicitation of requirements. You have to go and speak to the people that will use that piece of software and understand how you should implement that software. And then you come up with nice architectural designs, right, that have different views of the software that you're developing, like blueprints, right? So that the person who is writing the source code will be able to understand how they should implement the source code. You know, so they'll show you weird things like, or you produce weird things like high-level architectural diagram, right, that will showcase like the different layers, right? It's common to have what they call a three-tier architecture, architecture or something. That's fine. It's common to showcase what's called a three-tier architecture, and when a professional looks at this three-tier architecture, they'll know exactly how they should go about implementing the piece of software. And then also, what's important is the fact that software, irrespective of the type of software you're dealing with, software is designed for a specific target platform, for a specific operating system, right? So specific hardware, software that can run on embedded computer systems may not necessarily run on microcomputers or server computer systems. Software that is meant for, so I could be running, right? I could have this laptop here, but if the architecture, the CPU architecture, is not consistent with the software that I would want to download, I will fail to install that. Not all the time, but most of the time. Usually, if you look at Windows, they will say if you have a 64-bit architecture, a 64-bit hardware, you can install the 2-bit applications, but not vice versa. So if the 2-bit hardware, you can't install 64-bit software, right? But these days, the good news is that most of these hardware are 64-bit anyway. But, so we did that, and then we were essentially just setting the stage for a discussion where we're going to look at the different broad categories associated with computer software, right? Which is application software and system software. And on that note, so we're supposed to now start looking at just a brief outline of this so-called application software. So simply put, right, we have computer software. What we're saying is that computer software is, in essence, at a very high level of abstraction. That's another example in dealing with software and abstraction. You can view software as comprising of application software and system software. Ideally, application software is there to aid the end users, the human beings, to perform specific computing tasks or operations, right? These specific tasks or operations would be sending an email, sending a message via WhatsApp, authoring a document or writing an assignment, uploading an assignment to Moodle, right? These are specific tasks. This is why you need application software. Something else that you may wish to know is that for the most part, application software is implemented using high-level programming languages. I've told most of people I know, they know that sometimes there could be an emergency, but we must work. An emergency will be attended to at a later stage. I hope this won't, I don't want to shift around my pocket. I hope this emergency won't, I mean, I hope, yeah, it's an emergency. But anyway, so, yeah, application software is generally implemented using high-level programming languages, right? Like Java, like one of the early versions of Fortran, apparently in, is it generation number 2, is it? Oh, we had early versions of Fortran. Fortran is an example of high-level programming language, right? And we know what this means. If you're saying you are implementing application software using a high-level programming language, the people that are implementing that software can quickly write the software. So if you're writing something like a software application like SIS or like the UNZA website, the reason you would want to use a high-level programming language is so that you can quickly develop that piece of software. It would take you a long time if you decided, well, I'm going to use machine code to write, to design the website. It's possible, right? Where people that write websites will tell you, well, we use HTML and CSS and whatnot, but you can actually write that website using ones and zeros. It's possible. But why would you want to do that, right? When your goal is to write, to quickly ship product. You're not really, usually when you're dealing with application software, especially these days, the obsession is not, oh, I want to write efficient code or a piece of software that is going to consume very little RAM, right? Or use up very little processing power. No, right? That's not usually the obsession. You want to leave that heavy lifting to the system software that application software is going to go through to instruct the hardware on what to do, right? So browsers are examples of application software. Specialized tasks, right? You're performing a specific computing problem. You're using a browser to access a service that is located or hosted on a server computer system somewhere out there in the cloud or something, on the internet, or on the network. Yeah? The reason I normally cross out Visual Basic here is it's meant to be a joke. I've never really been a big fan of Visual Basic, but I have used Visual Basic before. I know most of you probably used Visual Basic in grade 12 or something if you did computer studies. But Visual Basic is also a high-level programming language, right? Right. So if you think about this sort of application software, again, not all the time, but usually application software is designed to run on, on desktop applications or mobile. Desktop computers, rather microcomputers for the most part. So you're looking at applications that are designed to be executed on a desktop computer or a laptop like this, or a mobile device, your smartphone, right? Those are all application software. Of course, there are certain types of software applications you soon see, but operate in very strange ways, right? But also, if you sit down and think about it, application software would also be generally designed to run on like server computer systems, right? Because you're still performing a specific computing problem. If you're saying you're going to develop Moodle and install it on a server computer system, Moodle is being designed to perform a specific task, right? Serve Moodle resources to whoever wants to access that, that Moodle application. Yeah? Anyway, I mean, so again, I mean, if you do look at desktop applications, I mean, these are applications that would be explicitly designed to run on devices that are associated with a significantly larger form factor, like a large screen, LCD screen, for instance, right? So that you can easily click whatever buttons you want, right? And then your mobile applications would be these applications that will run on microcomputers with a significantly smaller form factor. Yeah, and this makes sense, right? Like if the moment you start dealing with tablets, you know that the software has to be designed in such a way that maybe you can use your touch screen or something. So granted, increasingly some desktop computers will have that feature here, but you can easily use your touch screen, right? The form controls, right, can easily fit on a very small window or something. Yeah. Yeah, again, I mean, if you look at mobile applications, this will be deployed on mobile devices, right? Different types of mobile devices. What's crucial here is to appreciate the fact that all of these, right, would literally be classified, perhaps not smartwatches, but your smartphones and your tablets can be classified as microcomputers, right? And you know what smartwatches are? Here's a question for us, right? We must think about this. Is a smartwatch, does it fall under the broader categories of microcomputers or embedded computer system? Embedded? Why? Okay. Okay. So you're saying a smartwatch in your case is what? Okay. That's interesting. I mean, so you may be, some of you may be confused because maybe you may not have interacted with a smartwatch at length. But he's raising important points here. He's citing examples of different things you can do with a smartwatch, right? What's interesting is that there are dedicated operating systems for the smartwatches, right? The moment you're dealing with an operating system, you'll soon discover that you need an operating system to be able to manage resources, right? Resource utilization by the different applications that are going to be running. The reason I need an operating system on my laptop, one of the fundamental reasons why I need that is because at any given point in time, I'll be using a number of applications. So how do we manage resources that are being used by browser, right? By Ocular, by Kate, right? By all these different applications. Ooh, by OBS, which by the way is a desktop application, right? That I use to record screencasts. That's a specific purpose here. So a smartwatch is a microcomputer, yes. Anyways, what's interesting here is, I mean, if you look at some interesting things to pay particular attention to here is, in as much as when you're dealing with mobile applications, in most instances, you would have to literally explicitly install the applications. You go to Play Store or something and then download the application and install it, like on your smartphone. But it turns out that there are services, right, that would generally be available on a server computer system that you'd access using a browser, just like you would use a browser on a laptop or a desktop computer. So the point we're trying to put across here is that in as much as you have dedicated mobile applications that you have to explicitly install on your mobile device, in some instances, in most instances actually, you will find yourself opening up Chrome, right? And you want to visit some website. Boom, right? And you use that browser to access the different applications. Those applications are not associated with a mobile device. But the application that will be associated with the mobile device is what? The mobile web browser that you are using, right? As a conduit to access the service you want. The other example here is we've given examples of like USSD-based applications as well. It's not like when you dial *114#, it's not like you have this application that shows you what you see here is installed on your phone. No, right? You use an inbuilt application, right, that facilitates you being able to interact with your telco, right, your mobile service provider, right? Like if you right now I use MTN. Yeah, I use MTN. If I type *114#, what I'm doing is I'm accessing an application, right, that is hosted on a server computer system, on some MTN server somewhere out there. I hope MTN have their servers here, not in the cloud, right, because they'll be going against the Data Protection Act. But the question is, what would be the mobile application being used then? That's an interesting question. Given a scenario where for you to check your balance, in Zambia, you type *114#. What type of mobile application would you be using to access, to be able to type *114#? What application do you use? Sorry? The phone app, right? Yeah, so you click, don't you click on an icon called phone? Yeah, that's a piece of software, right? It behaves differently. When you type mom or dad's phone number, it allows you to call mom or dad. But when you type in * with a code and hash, it interacts with a remote service, a USSD-based service on your mobile service provider, right? So the phone app would be the mobile app in this case, not the application that shows you the responses. There you go. I hope you've learned something new there. Again, just showcasing, because when talking about mobile applications, people start thinking about their smartphones. We know where to get them, right? Play Store has everything. This is where we normally go when we want to install mobile applications. Not all the time, but in most instances. Like those of you that have a lot of money to splurge here, probably have iPhones, right? You go elsewhere. I don't know where we go for iPhones here. I've never owned an iPhone here. Too expensive, right? But there's no reason also to use an iPhone. Where do you go when you're dealing with an iPhone? App Store, right? How about when you're using a Windows phone? You know that once upon a time there was Windows mobile operating system, right? I don't know if it's still there. Where it's been phased out, right? I don't know. So typically, right? You know where to go when you're looking for these applications. But also you can do the same thing you do when you're looking for software to download and install on your phone, right? You go on the internet and you search, download Windows or download Microsoft Office. And then you click on search, you click on a link where you have a place where there's a huge download button, you click it, you download it. You can do the same thing for mobile apps, right? You can search for an app and then you download a .apk file if you're using Android, for instance. Right? And then you install it. Although your Android operating system will warn you if you've tried that. Say you are installing this from an unsecure source. The beauty of downloading mobile applications from Play Store is there's some sort of verification, right? The likelihood of you ending up installing malicious software is quite low. Anyway, thought I'll mention that. Back and forth is always nice here, right? Again, we already mentioned here, the desktop applications typically be designed to run on something with significantly large form factor, right? Again, you'd have to explicitly install these applications for them to run on your, take that with a grain of salt, this is what we have. In most instances, you must download the application and then execute it so that you install it on your machine for you to use it. If you want to use Microsoft Word and you don't have it, you go on the internet, you download it, and then you install it. Download and install. Or you go in a shop, right? For whatever reason here these days, you go in a shop and say, I want to buy, there are places where they'll sell this, they make a lot of money actually. We've come to buy Microsoft Office. What they'll do then is they'll give you a CD. It's the same process, right? Give you a CD and then you, well, things have changed now. New computers don't have CD-ROM drives, right? But they'll give you a CD and then you use that CD to install the software, right? Why do we have to go and buy software when we can download it for free? Yes? Well, how can it be hard to download software these days? Come on, let's be. So then you'd use us as a reason to go and buy software, because you're wanting to search for it online. It takes you to different sites, and then you go and pull out your 10,000. Say I want to buy software. No, we buy software because, and we have a discussion I believe about this, because there are different business models, right? Some software is freely available for you to download and install, whilst some software is commercial. So in as much as you people, I know you go out there and you go and install illegal versions of Windows, cracked versions of specific applications, you're doing the wrong things, you're stealing, apparently. Well, not really stealing, but you're doing the wrong things, right? I don't know what stealing is. Stealing is like if you get something and somebody won't have access to it. Like if somebody gets this laptop, right? I'm asking a question here. Somebody comes here and gets this laptop and I come in and I can't find it. They've stolen, right? But what if I have a copy of Microsoft Word, I've purchased it legally, and I duplicate it. I give somebody a copy. Is that stealing when the original copy is still there? This is the thing here, right? Are we really stealing here? We can duplicate software. I don't know. I don't know about whether we are stealing there, but we are doing something illegal, right? Because there's usually a licensing agreement that stipulates that you must use this software in a certain way. You can't use it if you haven't purchased a license. But some people will just ignore that, right? Even though they are very pious individuals, you go to church, but you use illegal software, you're doing the wrong things, that's fine. I don't think God or the gods would be very angry to say we store software in our life or something when we're alive, I don't know. But we'll have a discussion about that. I like that discussion when we look at business models, right? Because it sounds funny here, but this is a very interesting question, right? And the reason why it's interesting is because people look at this from different angles, right? Which is why people can freely just share software illegally with other people, right? I have a version of Windows, a legal version of Windows, and then you give it to all your classmates or something. Because to you, there's really nothing wrong about that. But you will feel the pain when you, hopefully, find yourself writing software. You want to get paid, right? You've spent time, your hard-earned time, creating that software. You want to make money out of it. I mean, if somebody is giving that software for free, I mean, you would not be happy. It's unfair. But anyways, so the interesting thing about desktop-based applications is there's a whole new breed of applications these days, right? They're called portable applications. They are desktop applications, but what sets them apart from these classic desktop-based applications is you don't necessarily have to install the software. When you download a portable app, you can use it without really installing it. I used to do that a lot, actually, especially when I found myself in a situation where, because I use Linux, and if I know that I'm going to be interacting with people that are going to be using Windows, I'll download portable applications, put them on my flash. And as we are doing whatever it is we're doing, maybe it's a workshop, we'll be using a portable application. So all you do is just double click it. You don't have to install it, because it's later when you're installing software here, associating or you're creating registry keys and all those weird things, right? But anyway, so you can run these portable applications without really installing them. So you just execute them from any storage medium, really. A thumb drive or an external drive works. And we're just showcasing examples here of desktop applications, just screenshot showcasing desktop applications on different operating systems, trying to emphasize or underscore the importance of, or that statement that says, application software is created for a specific target hardware platform and a specific operating system. What you're seeing now are applications that are meant for Kubuntu, right? Yeah. And you get packages to install on Kubuntu. If you just go to packages.ubuntu.com, you'd find software that's like the equivalent of Play Store. The beauty, though, I don't know if Windows has implemented this. The other beauty of working with a platform like this is I really don't have to explicitly go here and install software. So if I wanted to install I can't really think of a piece of software, but let's say I don't have a software called Vim installed here, and I wanted to install it. I don't have to go here and search for it or go online and search for Vim. What I'll do is there's a command that allows me to. I'll just say install Vim, right? And then what happens here is this thing is going to interact. It's telling me 0 upgraded and 0 new installed because I already have Vim installed. But the interesting thing about what's happening here is this application called apt-get, right, goes onto the internet, right, and interacts with a server computer system that has a list of all applications, right, associated with Ubuntu. And then it checks to see, is this Vim application available there or something? I thought I would use this as an example. apt-get would be like a desktop application or something. But the way it works is it's interacting with an application or application software. Well, this is application software that is located on a server computer system, right? That saves these different packages, and then I would be able to install it. It's unlike Windows where you go somewhere and then you click download and then you say install. I don't know if things have changed on Windows here. But if you guys wish to go and poke around this whole world of portable applications, please go to portableapps.com. You shall find the details. This is just an example of the platform where you find the list of software applications, portable apps. You can actually download these apps and use them without installing them. If you don't have a computer, classic example, you don't have a computer and you have a friend who has a computer, but your friend doesn't do ICTs, and at some point there's some type of software that you need to use to do an assignment. You download a portable app, you put it on your flash, and then you go to your friend, can I use your computer? Right? Plug in your flash, and then you execute that application, you do your work. Classic example of how you would want to use portable apps. Right? You go to the Library Investment Computer Laboratory. They have restrictions on what sort of applications you can install there. In fact, I don't think you have permissions to install software there. But if there's some obscure software that you need to work with, because you're working on an assignment in some weird course in your program you're pursuing, what you do is you go with your thumb drive, right, with your portable apps there, and then you just execute them. They'll run. You don't have to install them. You don't need admin privileges, they say, for you to install that piece of software or to work with that piece of software. Do you understand, people? People of Agrabah. So, yeah. I'm looking at the time here. But we started late. We can continue slightly, right? Started. You have what? You have class? Sorry? Sorry? Oh, you teach it? Which TG is that? Okay. But why would you have a TG? We would have spent the whole morning with Lighton, right? And get to bond here. I'll see you when you see me, which is, please prepare for the quiz, right? Read up on abstraction, different ways of, taking advantage of abstraction, right? Those weird examples we were showcasing. Yeah, the Von-Neumann model, right, where we abstract, or some of the ways in which the key functionality of the computer system is abstracted. Well, a computer is viewed as a black box that accepts input, processes the input, and provides output. But in actual fact, right, if you look at the high-level functional unit, you have specific components that are dedicated to performing those functions. Like you have the input functional unit, processor, or a CPU, a memory unit, right? Those are the things we're expecting we're expecting from you on Thursday, a day before the long holiday. That would be nice. It's a nice way of, I think it would be a nice way of pausing, right? With the quiz number 3. I'll see you when you see me. I haven't found a venue yet, sadly. I'm hoping the assistant dean hasn't confirmed the venue. And the only slots that are available here, and I want to pause, I want to throw this at you. If you can consider an 18 hours class on Fridays, there's a venue available, but I'll try and see if there's another venue. So that's an option. And I know most minors are available at 18 hours on Friday. We'll then be going to the library auditorium. That way, we would not disadvantage some of our colleagues that are not here because they're Adventists, right? Even though, I don't know if UNZA is a secular institution here, I haven't seen anything to that effect, but if you schedule classes on Saturday, then what are we saying, right? But we try to be fair in this course, right? So if we can change some of these things, we'd want to change them. Do you understand this? So as I'm looking for a venue, if we have trouble finding a venue, you can discuss this, and our course reps will maybe oversee this whole thing. I know incidentally the other course rep is an Adventist, right? Which is why he's not here, apparently, right? So do you understand this? Thank you very much. I'll see you when you see me. If you haven't filled out your name, please, if you haven't filled out, what I'll ask of you, there's a couple of things. If you notice, and I've shared this, I'll share this on Moodle. If you notice that you were unfairly graded, you must reach out to me, right? A human being marks this, there are mistakes that are made. So if there's a mistake that has been made, let me know. Some of you did not write your computer numbers. If your computer number is missing here, reach out to me. You can come and see me in 515, the office hours, or you can just send me an email address with, you take a snapshot, right? You take a snapshot of your script and you say, hi, I'm a student in ICT 1110. I did not specify my computer number here. Could you please update my grades, right? Those of you that have started using Moodle, the gradebook will be updated, but if you haven't, no need to stress, right? That's the other thing. Also, it's always a good idea I always encourage students, when you get these scripts, just get a snapshot of this and keep it for your records, right? It doesn't matter what the score is, because sometimes towards the end when you're comparing scores, mistakes will be made, and then you need to request that adjustments be made, right? Say, oh, you didn't include the score for quiz number 2. Well, where's the proof, right? Well, here's the image or something. Do you understand this? If you can keep your photos, if you can keep your photos on your phone or sync them somewhere, you can keep the photos of the scripts, right? There we go. By the way, something here. I know it sounds like I'm joking here, but don't stress about it for the scores. The performance was bad across the board. Doesn't matter what score you got. Redemption is in sight. Like, for instance, quiz number 3, we will redeem ourselves, right? My redeem and all that. Thank you. Do not stress.